fundamentals. Meet Faye, a wheelchair athlete who has the condition known as cerebral palsy. Cerebral palsy is a group of disorders that affects a person's ability to move and maintain balance. Persons with cerebral palsy often have weaknesses in their muscles. As such, Faye experiences many challenges in life, including limited mobility. Faye also experiences decreased independence owing to the fact that her father has to clean her wheelchair for her.
So who are we? We are Team Turtles consisting of Lin Qianyu, Chloe Ong, and Tan Min Min, 3 Year 3 students from Raffles Girls' School Secondary. As we are very passionate about making a difference to society, we are so very excited to be here today, presenting our solution to create an easy-to-use device for persons with cerebral palsy to clean their wheelchairs daily.
Like Faye, many people with cerebral palsy experiences many challenges in cleaning, such as reaching hard-to-reach areas, cleaning non-flat surfaces, scrubbing surfaces, and refilling and applying cleaning solutions. However, wheelchairs should ideally be cleaned daily, as it helps protect the wheelchair against mold, mites, and bedbugs. An automated solution to clean wheelchairs reduces the dependence on others for cleaning wheelchairs. Even if we cannot fully automate every single step of the cleaning, and that some level of reliance is still required, many users will feel a sense of satisfaction when they get to rely less on others. This is what we hope to achieve.
So who are our beneficiaries? Our beneficiaries are people with cerebral palsy and their caregivers. Our community partner who gave us the problem statement is the Cerebral Palsy Alliance Singapore, which seeks to empower persons with cerebral palsy or multiple disabilities to realize their full potential and lead fulfilled, dignified lives. CPAS provides persons with cerebral palsy and multiple disabilities with early intervention, special education and rehabilitation services, day activity center programs, as well as vocational training and gainful employment in Singapore.
Next, we'll be talking about how we generated our ideas. We have set the following criteria for our design to provide an excellent user experience. Firstly, it will require minimal force. Since cerebral palsy hinders movement and reduces mobility, increasing automation will make it more convenient for them to use. We also want it to be easy to understand how to use. As this device promotes independence, we hope users can use it on their own with minimal assistance. Since we want our product to be more accessible to people, it should be economically friendly. Since space is limited, we wanted it to take up little to no extra space. Needless to say, we also took the safety of the user into consideration when designing our cleaner and applied stability and rigidity concepts on our device.
Our research centers around 3 parts and is done through online articles and interviews with beneficiaries and CPAS. Firstly, we researched the parts that should be cleaned. We found out which parts should be cleaned most regularly, such as daily, and are the most difficult to clean. The areas we shortlisted for our first prototype were the seat and backrest. Next, we researched on a cleaning method that is both safe and fast. Lastly, we determined that the device will be controlled by levers or large buttons, as they can be controlled by our beneficiaries. From our interviews, the beneficiaries all say that they will be more than happy if a device could work. The person doing the cleaning is mostly the caretaker and not the users themselves, which will indicate that the wheelchair users living on their own may have problems cleaning a wheelchair manually. More surprisingly, a wheelchair user who cleans the wheelchair herself mentioned that the wheelchair is sometimes dirty, but she's embarrassed to send it for service. All in all, a device seemed to be desired. So we put our thinking caps on. Our first idea was a circular robot that consists of 2 semicircles, a heavier back end sticking to one spot on the wheelchair, and a lighter front part which extends with a telescoping mechanism to reach far areas of the wheelchair for cleaning.
During the second round of ideation, we decided that we needed to reduce the cost as well as increase the speed of the product. Here is our Lotus Blossom ideation method. In order to make the product less costly, we decided to do away with the camera as well as minimize the number of motors we used. To make the cleaning process faster, we also decided that we needed to increase the surface area covered by the product at any point. From there, we generated 3 designs, which mostly required the changing of axes, which was hard to coordinate and consisted of obstruction and distance issues.
After countless ideation sessions, eureka! We finally settled on an idea. The wheelchair is cleaned by the rubbing of sponges against the backrest and seat cushions. The sponges sit on top of a cloth acting as a conveyor belt, drawn by a timing belt, which is moved by an EMA 17 side stepper motor. It is controlled by L29N motor, shield, and an Arduino Uno. The sponges are attached to the cloth using Velcro and can be removed from the cloth for easy cleaning. Due to the large surface area of the wheelchair, using a light and small device will require more electrical components, such as motors and cameras, thereby adding unnecessary complexity to our device and increasing the cost. We therefore settled for a bigger device that can stand on its own. Although much heavier and larger than what our community partner has hoped for, this device need not be lifted or handled by the user, and a wheelchair can easily park under it, thereby fulfilling the same criteria as a lighter design. On the left, as you can see and hear, the motor moves the cloth up and down, and it starts on very slow speed and slowly accelerates. This is to overcome any inertia and to ensure the motor can accelerate to its full speed. On the right, this is what our stand looks like. We use brackets to extend about 20 cm from the cleaner to accommodate for the armrest and the wheels of the wheelchair. This enables the user to push the wheelchair easily from the back of the device instead of lifting up the whole device just to put a wheelchair. Our stand is made of wood, and we use triangular pieces of wood to reinforce the stand.
So what can our product achieve? Our product aims to be labor saving, time saving, and cost saving. To use our product, one only needs to place it on the wheelchair and leave it there for a few minutes, as compared to having to wipe down the wheelchair manually. Washing the product will also not be cumbersome since the sponges can be detached to be cleaned. The device can also function with no additional effort from the user, freeing up time for the user and the caretaker to do other methods. Our product also contains very few expensive parts, the only costly part being a singular motor. It doesn't require sensors or cameras and can therefore be mass-produced without much cost incurred. All in all, our product can increase independence of individuals with cerebral palsy with minimal cost and effort. During the course of the 3 months, we did research and interview, designing, prototyping, and the first round of testing. However, we can definitely go beyond this by researching more into materials and improving our current prototype, as well as implementing guiding sound effects and instructions to make our product safer and easier to use. Additionally, we also want to do second round testing with more users in order to troubleshoot. Finally, we would also like to make our stand adjustable to accommodate wheelchairs of different sizes.
This is Team Turtle signing off. Thank you for your kind attention and have a great day ahead. If you have any questions, do not hesitate to ask us. Thank you.
Thank you for your presentation. Okay, maybe I could ask, what do you guys think was the most challenging thing working on this project? Like amongst all the challenges that you face.
So we believe that the most challenging thing was actually to find a space to work, because our project is mainly hardware, and we need stuff like wood cutters and scroll saws to actually make our product. But due to the pandemic, we couldn't actually go back to school as often or go to maker spaces. So a hard part was to actually bring back the materials and try to figure them out, how to connect all of them on our own without any very advanced machinery. Yeah. Thank you.
Oh, so you guys ended up doing it all in your houses? Was that the solution to overcome this challenge?
Yeah, we ended up doing most of the things in our house, but we did cut some wood in school, but that's about it.
Oh, okay. Okay. Thank you for presenting Team Turtles.